So the main purpose of this video is to set up a relatively budget 10 gigabit network connection between my PC using this ASUS card and my QNAP NAS using this expansion card, and the use of a single wire to connect the two devices together. The cable I'm using here is a Amazon basis Cat7 cable, and though Cat7 is not officially certified, you could get away with a 10 gigabit connection on a Cat5e and a Cat6 cable, though I would recommend to check the distances that are supported by each of those cables before using them for your setup. And then to achieve that 10 gigabit speed, we're going to be using a cache based on two WD-SN770 black NVMEs inside this QNAP expansion card. And with all of that out of the way, let's get started. Hey everyone, welcome back to TK's Tech Talk. I'm TK and this is TTKK, or better known as the Trusty Kitchen Knife. And today we're going to be unboxing these two 10GBE PCIe expansion cards. So on the right we have the QNAP QM2-2P10G1TB, and on the left we have the ASUS 10 gigabit XG-C100C Ethernet card. And in the background here you can see this is my QNAP TS-664 NAS with which I plan to use the QM2-2P10G1TB. If I recall correctly, both of them have the Quantia chipset for the 10GBE, and I believe this is 107 and this one is 113 or something, and I think the A was the same chipset as this ASUS card. So what you notice about the QNAP card in this case here is that this particular model also has dual M.2 2280 PCIe NVMe slots, and though this card is a PCIe 3x8, I believe internally it operates at a PCIe 3x4. Now these PCIe specs are important because this particular NAS has a PCIe 3x2 expansion slot. In theory, PCIe 3x1 is about 1000 megabytes per second and PCIe 3x2 is about 2000 megabytes per second. So if our purpose of using this card is to attain 1000 megabytes per second from the LAN port and using the SSDs as cache, theoretically we should be able to get 1000 meg from the SSD and 1000 meg from the LAN port. So this card also works inside the PC, and what's nice about this is that it does not require bifurcation support from your motherboard. What does bifurcation mean? Well, basically, if you're attaching two SSDs on one card, your motherboard needs to be able to split the the lanes on the PCI Express slot, which will allow you to use two SSDs on the motherboard. However, this particular card actually does not require bifurcation. It does all of the stuff on board itself, and you should be able to see two SSDs on your PC in addition to that 10GB card if you use it on the PC. This card apparently works inside the QNAP as well. The only problem is the plates included, even the low profile one, have this L-shaped bracket. That bracket will not fit inside this NAS in the desired way. And unfortunately, the only way to make it work, as far as I know, is to remove the plate altogether. I will try and do some testing with this, but that will be for another video. The main purpose here is to get this card installed in the NAS, to get this card installed in the PC, and directly wire them, because you can literally do direct wire. They don't need to be crossover or anything, and it should just work out of the box. So let's start by unboxing both of these devices and see what we find inside. Okay, so let's unbox this ASUS card. Can't be too much inside, I guess. Should be pretty straightforward. Just a PCIe card. I think the TP-Link one is actually also red. It looks very similar. I think they all use very similar chipsets. You know, people do have different varying levels of connectivity. Some people say that it cuts out. We'll only find out in one way. So there's the card itself. It's a very nice looking card, very small. There's our RJ45 port and the LEDs. And let's see what else is inside the box. VIP warranty notice, user manual, the low profile bracket, which again probably won't fit inside the QNAP, but it can just be removed completely if you want to use it inside the QNAP, and the ancient CD-ROM. Right, let's get rid of all of this stuff. One thing I wanted to point out is that this card has a PCIe 3 X4 connector, and I will be installing this in an MSI Z690 motherboard into a PCI X16 slot, which is pinned out at PCIe 3 X4. And this shouldn't pose any problems because the card will not require anywhere near the full bandwidth of PCIe 3 X4 to support 10 gigabits. So let's get inside my PC and put this card in. Okay, so we're inside my PC and you can just about see these two PCIe X16 slots, and these are both operating at PCIe X4. I think you can just about see the pins there. They finish around there on that bottom slot. This is an MSI Z690 Edge Wi-Fi D4 in case you're interested, and I'm going to be using that top slot which you can just about see there. So let me get the card and let's put it in. Okay, there we go, the card is installed. So let's get this PC booted and see if it detects the card. Okay, so the PC has booted without any issues, and the card was automatically detected and installed. There was no drivers required, and you can see it here under network adapters in device manager as ASUS XG-C100C 10G network adapter. And on the right here I have the Ethernet status open, which shows that the speed is currently 10 gigabits because this is connected to a 10 gigabit port on my NAS. So now let's get back to unboxing the QNAP 10GB card and put it inside the NAS. Okay, so let's open up this QNAP device, see what we get inside. I'm guessing they want much more than a card and maybe a manual or something. Right, there's the card itself. And let's see what else there is inside the box. So we have a couple of plates for the ports, well, obviously one port only, and there's actually already one on there. And what you notice is the difference here is there's an L-shaped bracket there, there's an L-shaped bracket there, and they've even thought about those devices that might not support the standard bracket. So this would just be a flush port and it should fit in more devices. So that's nice of them to include that. And then we've got these thermal pads, I believe, for the NVMEs, and some screws probably to put everything inside. Some label, and what looks like the installation guide. Let's see quickly what it shows in here. Do they talk about the driver at all? Not really, just talks about how to install it inside your PC or inside the QNAP. That's fine. There's some more instructions on the back as well of how to install the SSDs and things like that. But we'll come to all of that later on. And nothing else is inside the box. Thankfully, no CD-ROMs. Okay, so let's get a closer look at this card. It's a fairly compact card. Feels quite lightweight. So there's our 10GBE RJ45 port there, and the heatsink there for the SSDs. We'll have a look at inside later. So this is the PCIe 3 X8 slot. And again, inside it's just working as a PCIe 3 X4 if I remember correctly. And that means it's more than enough bandwidth on a PC at least for us to use the two NVMEs as well as the 10 GBE connection, which is about 1000 megabytes per second. So inside the TS-664, we have a PCIe 3 X2. And that is an open-ended card, so this card will comfortably fit inside. It's actually part of their compatibility list, so it will definitely fit inside. And the only limitation there is that we will get the 1000 meg for this. Both of the drives will also share a 1000 meg connection. In my opinion, it's fine because my main aim of this card is to achieve the 1000 megasecond using these two drives as cache. So theoretically, two NVMEs will easily be able to give us 1000 megasecond shared, and also 1000 megasecond from the port for the connectivity to our PC itself. So let's get this all installed. Okay, now we're going to install two 1TB SN770 black drives, and the way to do that is by removing these 4 screws. So let me remove the screws and we can install the drives. Okay, so I've opened all the screws up, installed one of the SSDs already. My thermal pad seems to be a little bit cracked. I think there is people reporting that the thermal pads break easily, and this one was also off place, so I've just positioned it back onto the chipset there. So there is actually a temperature sensor here, so that is good because we can monitor the SSD temperatures. And we've already installed one in slot 1, so top one is slot 1 and the bottom one there is slot 2. Let me just zoom in so we can see it better. Okay, I would recommend maybe removing the fan connector, but I am doing things very carefully here, so I guess it should be fine for now. There is a temperature sensor here which sits under the SSD, and all we need to do is line up the slots on the SSD and the card, push it in, pull out this tab, push it down, and push it back in. As simple as that. Okay, so we're now going to install the thermal pads that came included inside the accessories and make sure the controller and everything is covered. So let's try and do that. And then we can peel off the plastic. These pads are very sticky. I did read a report somewhere that they'll be a bit messy afterwards, but I don't have anything which is the same thickness, so I'll just have to go with these for now. And there we go. So now we can screw all of this back up and see how it fits and works in the NAS. Right, so I've got my QNAP TS-664 here. You can see the back side of it here. I'm going to remove these screws which will allow the cover to come off. So let me just do that. Okay, so once all the screws are off, make sure the front panel is also removed and there's none of the stickers from factory remaining, and then you can just slide this off literally. And we have access to the internals. And there is our PCI Express slot right there. So we'll have to remove this one screw. So let me just get that out. Okay, so I got rid of the screw, the plate just fell out, and what we're going to do now is slide that card inside. So let me try and do this so that in a way that you can see it. I hope this works out. So let's get our card and just slot it inside. We need to remove this plate. This is what I was talking about earlier. This L bracket will not fit inside this NAS. So we're going to remove these two screws and put the other faceplate on. So once we've got the correct faceplate in, it should look something like this, and then we should just be able to slot that in to the slot like so. There we go. And then we can screw that back panel back in using the screw we removed from the plate. That's the camera there. There it is, this screw here. And we just need to put this screw inside and we are done. So let me get the covers back onto this thing. We'll power it up and see if the card and the drives are detected. Okay, the NAS has booted back up, and good news, the card has been detected. And if I just zoom in here, you can just about see there's a green light on that PCIe slot there. And this is my main network port, which you can see down here. So the 10 GB card is working correctly. Okay, I've minimized the view a little bit here so you can see that this is the 10 GB adapter here at the bottom and 2.5G at the top there. So this is the one that's on the NAS and this is the one that's on the adapter. So I've just clicked on the interfaces tab here on the left, and now you can see more information about the card. It shows 10 gigabits, shows QM2-2P10G1TB, which is the model number, and I've assigned this IP address and I've given it an MTU of 9000. And to do that, you just have to click on the three dots on the right here, click on configure, select, and then apply whatever you want for the MTU. So the jumbo frame, in this case, I've chosen 9000, and this will give us the full bandwidth of the 10 gigabits port. So now let's check if the drives have been detected correctly. So we can go into storage and snapshots. And here you can see M1 and M2. And these are the SSDs which are installed directly in the NAS, and both of them are 970 EVO plus 1 TB. And on the right here you can see P1M1 and P1M2. So these are the drives that are on the PCIe expansion card, and they are both WD-SN770 black as we installed. Okay, before doing anything with these SSDs, let's head over to my PC and copy a file to do a speed test. So here you can see a shared folder which is shared onto the NAS, the same IP address we saw earlier in the network properties on the NAS, and this is actually a VM's shared folder on the 970 EVO Plus SSDs. So if I open that up, I've got another test file open here which is about 73 gigabytes. So I'm going to copy this straight over the network and let's see how fast it is. And remember, this is connected directly via a single cable between my NAS and the PC. And there we go, we're hitting around 800 to 900 megabytes per second, which suggests that we're getting the full bandwidth, or at least almost the full bandwidth possible through this connection. And as we approach the end of this test, you can see we managed to maintain around 800 megabytes per second, and the fan has kicked in the back there. I'm not sure if you can hear that on the video. So I've just opened up the hardware information here, so we can see that those SSDs don't have any thermal pads or anything at the moment, and they're actually hit like 64 to 66 degrees. The fans are running considerably loud and at 2400 RPM at the moment, but the SN770s are still relatively cool because they're not really in action right now. So now we're going to create a cache and test that, but before we do that, let's just see how fast the hard drives are. So on the NAS here, I've got 2 disks which are WD Red 18 Pros, and I'm going to copy a file which is now on a share on the hard drive. So this Z1 is inside a test folder on the hard drives, and I'm going to copy the same file again, and let's see what sort of speeds we get. So you can see we've dropped straight down to 250, 200 megabytes per second, because we're now bottlenecked by the speed of the spinning disks. So even then 250 megasecond is fine, but we're already able to achieve that over the 2.5 GBE. So let's head back into the NAS. Let's click on cache acceleration, and we're going to create a new cache. We're going to click next, look for the spare drives, PCIe 1 slot, M.2 SSD 1 and 2, SN770 black. It's got this fire sign. I'm guessing that's because it's an M.2 PCIe card. I'm not sure. Let's do a write-only cache for now, and let's make it a RAID 1 so that we don't lose any data if the disk fails. I'm going to use all I/O to get a faster bandwidth. Click next, and we're going to use only the hard drives, which is the 18 terabyte capacity there, or 16 here, and this is the one that's on the physical disks. So let's create that cache, check everything, click create. I understand. Okay. Okay, the cache is now ready. It says write only, and the service is on and it's completely free at the moment, as you can see here. So now let's do exactly that same test again and see what happens this time. Right, so we're definitely getting more than the 250 megabytes per second, but we seem to be slowed down to around 580 megabytes per second by the cache. And I'm wondering now if that RAID 1 overhead and the limitation of this PCIe 3x2 slot has something to do with that. So let me stop this. Let's break that cache and recreate it as a single disk. So let's turn the service off, and it's going to flush the cache. Okay, the cache has finished flushing. Let's go to manage and remove. Okay, the cache is removed. So let's recreate it with just one disk, and we're going to get all sorts of warnings. So I'm going to do one disk. We're going to do write only. We're going to select next, enter the password, because obviously it wants me to confirm that I'm about to do something really silly. And I'm going to click all and next, and only select the hard drive as before. Click next and create. I understand all of the bad stuff. Click OK and wait. Right, so our single disk cache is ready, and we can verify that by going over to disks, and we can see this light blue color means cache and the gray one is free. So only one disk now is being used for the cache. So let's do that test all over again. Let's go to our shared folder and make sure that it's the correct one. Yep. And copy the same file again, and let's see what happens now. Well, that's interesting. We're getting over 800 megabytes per second. 900 megabytes per second. So it looks like that single disk cache is working way better, which means that the RAID 1 overhead and of course the limitations of that port are hindering us with the RAID 1, and we're getting slower speeds. But now I've got another idea. So let's stop this. Okay, so I want to try something interesting. What we're going to do is we're going to click on disks here, and I want to have one cache drive on one of these slots and one cache drive on one of these slots in a RAID 1. So that will help us share the bandwidth between the host M.2 slots and the PCIe slots on the 10 GBE card. So what I'm going to do now, I'm going to shut the NAS down. I'm going to take out the 970 Evo Plus from this slot here, and the SN770 from this slot here, and we're going to swap them around. And that can be swapped without any issues. We don't need to worry about the RAID configuration. It will just detect that the drive has moved into this slot, and it will just use it like that. So let me do that. Okay, so I've replaced the drives, and I've decided to put the 970 EVO Plus on slot 1 and the WD Black SN770 on slot 2, and in the NAS both drives are also in slot 1 and slot 2. So let me close this all up, get the NAS booted, and we can continue testing. Right, so we're booted back in. Everything's fine, everything's been detected as it was before, and we can see here M.2 SSD 1, which is on the NAS, is 970 EVO plus 1 TB, and on the first slot on the PCIe, the P1 M1 or the PCIe 1 M.2 SSD 1 is also a 970 EVO plus 1 TB, and then here we have the two WD Blacks in both of the second ports respectively. And here you can see a lightning port. It shows the cache is still enabled even though we switched the disk. So let's just have a look at that. So there we go. And we moved the cache from here to here, and it's still there. We moved this SSD from here to here, and it's all still in RAID 1, working perfectly fine. Right, so let's delete this cache. Let's turn this off. Okay, the cache has finished flushing, so we can just remove it. So the cache is deleted. Let's go ahead and recreate it using the two SSDs that we moved around. So the first one is M.2 SSD 2, which is directly inside the NAS, SN770 1TB. And the other one is going to be the second one from the card, PCIe 1 M.2 SSD 2, which is also SN770 1TB. Let's create exactly the same cache again. Write only, RAID 1, click next. Use all I/O, click next, select only the data volume which is on the physical disk, and click create. I understand. Okay, so the cache is now ready, and let's try that PC transfer test again. So I've got my test folder here as before on the hard drive on the NAS as a share, and I've got my local test.dump file as before, and we're going to copy this file and see what sort of speed we get. So this is interesting. So we're getting around 800, well over 700 to 800 megabytes per second. And this is considerably faster than the 600 megabytes per second we were getting with both the drives directly on the 10 GB card itself. So it looks like there's something to do with the bandwidth allocation, and by spreading that bandwidth across the two different controllers, we're able to sustain a much better speed. Now it's quite possible that if we were actually doing some work on the NAS, on the 970 EVO Plus, which is the OS drive, it might have a slight impact on this, but if the PC is idle and you're just copying, then I guess it should be fine. So let's stop this. And let's go back to the NAS, and we can see here it says allocated 4%. That means 4% of the space has been used by that cache data that we just wrote to the hard drive, and eventually it will clear off the SSD and onto the hard drive. Okay, I think that's it for this video, and we saw some interesting stuff with how this card works, and we're able to get some decent speeds. The 10 GB connection directly between the PC on the ASUS card and this QNAP card on the NAS is working pretty well. The cache acceleration works pretty decently as well, especially if we split up the NVMe drives amongst the NAS and the PCIe card. So once again, thanks for watching. Please feel free to ask any questions. Please feel free to like and subscribe, and I'll see you in the next one.